lecture later? Okay, so thank you everyone for joining. So this lecture is going to be about 3 lessons about GitHub Copilot that will boost your Python code. Recording in progress. And as Brian introduced me, I'm Hila. I have an undergraduate degree in applied mathematics. I have a master's degree in information management systems from Harvard Extension School. And right now I'm finishing my second master's in data science, also from Harvard Extension School. And I do enjoy teaching in non-conventional ways. I did publish a Udemy course with one of my Harvard professors about Introduction to Advanced Python for Data Science and Machine Learning Operations. And I also have a TikTok channel, as Brian introduced earlier. But I'm here to talk to you today about a book that was recently launched, Supercharged Coding with GenAI. I authored it with one of my other Harvard professors, Dr. Peter Henstock. And when we were researching how to code with different GenAI applications like OpenAI API, ChatGPT, and GitHub Copilot, we actually spent more than 600 hours researching that domain because we felt that there is a lot of dissonance in that area. Brian mentioned earlier that the YouTube is filled with videos about vibe coding and flexing about it, right? We spin off one prompt and we get a complete application. But then when we were sitting down in our focus groups with practitioners and students, they felt like we are just getting started and we're not quite there yet, right? We turn on cursor, we turn on agent mode, we say, hi cursor, please help me to log my application, add loggings. And then what cursor agent mode will do is add a print statement. So how can that dissonance be where from one hand we get an entire application from one prompt and no code is required, but from the other hand, we can really get what we want. So we did spend a lot of time researching these different approaches to generating code with GenAI applications, and we were specifically focused on what prompting with code means. Should we add comments? Should we strictly use code? By the way, the answer is yes. We should strictly use just code. We will see that soon. We also talked about production quality, and we will see that throughout the lecture. What does code smell means? How can we dodge this bullet? Are we actually sewing off the branch we're sitting on? And we also wanted to take it a little bit further than just very trivial tasks. Because if Stack Overflow has starter guides that ChatGPT is able to change maybe the application or logo, that's fine for vibe coding. But can we take it to something that is beyond trivial and beyond starter kit guides out there? So we boiled down actually this book to a very quick 15 minutes, 3 lesson guide. Sometimes it extends to 90 minutes and then we add the 4th lesson. But we really boiled it down to 3 lessons focusing on GitHub Copilot and for a very good reason. By the way, the lessons we're going to learn also apply to cursor and feel free to type in chat or unmute yourself and say, hey, well, cursor does it better. Can you open cursor and let's explore that? So that's completely an option. But we really want to focus on the 3 lessons that we've seen that in the past year really supercharge practitioners and students' code and help them gain more trust and reliability from GenAI coding applications. So these 3 lessons are actually going to be based on the chapters of the book. We're going to start with understanding what prompting with code means compared to chatbots that we already know. We are then going to actually touch a pretty advanced topic from chapter 9 that has to do with prompt engineering techniques to expand the scoping of the output that we get. We will start with very simplistic constant and helper functions from chapter 3, but then we will go to complete modules and see how with very few coding statements we get the production quality quality module. We will then take a step back and talk a little bit about something that is called code smell, that is generated by GenAI, sometimes under our instructions, and understand how to dodge that bullet. And in 2 minutes about logistics, we will have a lot of engagement, right? I will need your help. We will have live coding sessions. I will need your help to understand how to complete my prompts, understand why we're getting the outputs that we're getting from Copilot. So feel free to either chat and Brian will speak out on your behalf, or you can just unmute yourself. We will also have plenty of time for questions, and actually we'll have it twice per lesson. So right after we conclude the live coding session, I'll tell you that this is time for questions, and also when we conclude each lesson. And in the end of that session that we have today, you will know when to use GenAI applications. You will understand better about the intuition and why we're getting the outputs that we're getting, and also how to practice more. So without further ado, unless anyone has any question, let us get into lesson one. All right, so in chapter 3 of the book, we dive right into how to prompt with code. And this is actually an interesting question, right? Because if we start ChatGPT and we say, "Hi, ChatGPT, please implement in Python the FizzBuzz problem," which is a typical coding exercise in job interviews. We will then probably hit enter and expect ChatGPT to give us Python code and maybe some supplementary explanation. But what happens after we install the GitHub Copilot application in VS Code, for example? We may just start this application. We will go to our IDE. We will type some code and suddenly Ghost Code appears. We haven't asked for it, but it will be there. Why is that happening? We haven't pressed any enter or any key. So it turns out that prompting with Copilot actually follows a pattern that is called Stacy. And if we take, for example, a constant definition in the Python syntax, we will typically see the name of the Python object. For example, if we define a constant, then that will be the syntactic flexibility that we get in each prompt. We will see that when we practice. This means that we have more flexibility in the name of the constant, which is unlikely to coding. This is mostly rigid, but we will see that. This is very cool. But then we will actually have to define the type. And type hints is not something that is enforced by Python, but when working with code generation applications, we will see how crucial that is to get a really quality output from the GenAI applications. But if I mentioned before that we'll have syntactic flexibility with defining the names of the objects or the constants, when it comes to types, we have to be actually very rigid. And when we change the type, we can no longer expect the same outputs from the GenAI application. And the last part on the Stacy prompt is actually the queue. So when we define a constant, for example, the queue will be the equal sign, and that will be the cue to Copilot saying, okay, this is time to complete your code here. And that's the time where you should actually assist us and supercharge that code. Whatever happens before we type that queue is called an early completion. And that actually happens when we stop typing for half a second. And this is actually something that really bothers practitioners when they first start typing in Copilot. They're saying, why are we getting an early completion? But actually, when we start working with these tools, it's pretty fine to ignore these early completions, wait for the entire prompt to complete, to have the name of the object, the type, and the queue, and only then mind the completion that we get. Now it's time for our first live coding session because we want to start working with VS Code. So what I'm going to do right now is actually send in chat 3 constants and 2 helper functions. What I need your help with is after I send these in chat is that I'm going to start my VS Code and I will need you to tell me what these constants and helper functions are. So what I'm going to do here is define a new Python file and let me open that tab. Can you see my VS Code now?
Yes,
Perfect. Is the resolution good?
I think so.
Okay, we will soon know. All right. So, can you please tell me what is the first constant that I've typed in the chat?
I'm letting the audience do this, so please, anyone
Yes,
who
please.
wants to
Yes.
come off of mute and
Mhm. Any volunteers that see the chat and can tell me what the first constant is?
see that Chen
Is
Cheng
it
is
the first line HTTP OK status?
Mhm. Perfect. So we see that we're already getting completions of Ghost code from Copilot, right? But we know that these are only early completions because I stopped typing. And having this name of constant is just the syntactic flexibility that we get. But we know that a prompt is not complete without having the type. So we like what is the type of the HCPOK status? What do we hope that it will be? Okay, Tian Cheng says it's a Boolean. So this is actually a nice observation if it's like true or false, if it's okay. But typically for front-end development, we're actually looking for integers for status code. So for example, the popular status code for OK in HTTP is actually 200. Like we see that Copilot here completes. I will add the queue and we see that 200 here. Now, we've talked about the syntactic flexibility, so we can pretty much expect when we type HTTP status OK, which is a different naming, we can still expect to get the same completion, right? Still get the 200 as an integer. But from the other hand, what happens if I change the type to string? I will then get a different completion, right? So therefore, when we first teach prompting with code, we say never ditch the type hints. It's crucial. Start with primitives, but go further when you work with more complex objects. And this is very crucial to get the results that you want, or in our case, the 200 as an integer instead of anything else, right? We could even do things that are weird, like floats or I don't know, like tuple, but that's just weird. Okay? So whenever we type our code, we will always stick to the Stacy method, having syntactic flexibility for the object name, type rigidity for the type hints, and then also a Q, which is an equal sign in our case. Okay, great. We have our first prompt for this afternoon. Now, I've typed in another constant there on that list, right? What was it?
The very light pink hex?
Yes, fantastic. So when we are working with front-end development, one of our biggest hassles is to define colors. And hex actually stands for the code of the color. And we already know that we have some syntactic flexibility, right? So it doesn't have to be very light pink. Maybe I'm up to Barbie pink, for example. Did I spell Barbie right? No, Barbie pink. And we want the hex. Now, we already know that we want type hints, and look how GitHub Copilot actually has a better early completion right now, right? When we started with the HTTP status code, we were not talking about type hints, but right now GitHub Copilot infers that I'm after the type hints. It will suggest a string, and it will suggest this string. Look at that. This is well, not the lightest pink, but it's definitely a Barbie one, right? Now let me ask you this. What happens if I didn't want to have an Xcode? What happened if I wanted an RGB? RGB stands for the tuple of RGB, right? We have blue, red, and green. So for that, actually, we wouldn't want to use the built-ins like tuple. We would want to go for the parameterized generics for the full form of tuple like this. Now, why would I say that I want the parameterized generic? Because having only a tuple is not rigid enough. Technically, we could say that we wanted the parameters inside to be floats or even string, right? But we want to do types that are as rigid as possible. So we will use the generic tuple and also define the parameters inside. By the way, this is an advanced question to the crowd. What do you think that Copilot will infer better, like complete better? RGB codes or hex codes? Any thoughts about that? This is like an advanced question, but yeah. Brian, do you have a thought about that or?
I mean, just the work that you did just to
Mhm,
do that
mhm,
triple there,
mhm.
I would go with hex as the simple.
Yes, yes. So you're 100% right. It turns out that actually code completion and GenAI applications in general are better with hex code, just because the training data contains more hex code, right? Because when we do front-end development, when we're working with applications like Wix, like Magento, like Shopify, they will typically use hex code. So it turns out the training data for the LLM models include much more hex codes than RGB. So I do recommend sticking to hex codes when you use code completions. So that's like a side branch. Okay, fantastic. So we've learned about parameterized generics. We've learned about the Stacy method, but now let's talk about composites a little bit. And by composites, I mean Python objects like lists and maybe even tuples and nested dictionaries. So let's go to the last and final constant for our live coding exercise. What was it? It's the third line in the chat. Can anyone see that?
Country phone codes.
Perfect. Thank you. So, country phone codes. Now, I don't live in the United States, so a lot like many times I have to fill in country codes. So for that, actually, I may want to have, for example, a dictionary, and that dictionary may entail a string for the country name and also a string for the country code. And this is actually interesting because this is one of the exercises that I recommend practitioners that are asking me which is better to use, GitHub Copilot or Cursor. And I say that the best way to choose one tool or the other is to experiment with some prompts. So whenever we handle composites, this is actually one of the best opportunities for us to see how these Gen AI applications work differently. And Cursor will typically suggest us a long list of countries, but Copilot will be like more sticking to one line per suggestion, like we see now. So, okay, we're getting a first suggestion of United States, but as I mentioned, I live in Cyprus. So I do get the country code of Cyprus, and maybe it will also propose Greece, which makes sense because we're neighbors. But maybe I will also want to get the US country code. Yeah, and so forth. So what we see here is that even when we want to get composites completions, we still have to stick to the parameterized generics form. And by the way, I'm currently using some type hint that is not yet defined. So if I go here and type FR or even just F, I see that the first completion by GitHub Copilot is actually completing the missing definition. And I'm not showing you that for nothing, actually, because when we move on to the next lesson about expanding the scope of completions, we will see that calling objects or definitions or imported packages that doesn't exist yet or are not defined yet are one of the best completions we can get from GitHub Copilot and GenAI applications in general. It also has to do with the training data, and lucky us data scientists to understand how training data work and also construct prompting methods based on that. Okay, wonderful. So enough about constants because we want to be more advanced a little bit. So let us understand how to prompt now helper functions. I do have in our exercise for today two helper functions. We can do just one. Please tell me what is the first function that I should complete with GitHub Copilot. It's in the chat right below country phone codes. It's definitely not that early completion. Can anyone find the next prompt that we should do?
I'll read from the chat. The get arithmetic mean.
Okay, fantastic. So get arithmetic mean basically means taking two numbers, adding these up, dividing by two, or when you have a longer list of numbers, then taking a bunch of numbers, dividing by n. We've all done it in the seventh grade or so. How do we define helper functions, right? Because we get a little bit of a different syntactic flexibility here, type rigidity, and also Q here. So if I type arithmetic mean, I already know that I can write average instead, right? It will mean nothing to GitHub Copilot. If I'm using straightforward terminology, then it's pretty fine to use whatever definition I want. It is important, though, to have get if we want to return a value or not to use the terminology get if we want to do like an in-place coding that returns nothing. And now comes the part when we have to stick to type rigidity, we have to define what our arguments are, right? Because if we get two numbers, for example, that are integers, that may change the completion from having a list of numbers, for example or even using different standard libraries that will completely change the completion that we get. So let's keep it very simplistic here, saying that we're getting just two numbers, and we want to include also as part of the type rigidity the return value as well, not just for the arguments. And instead of having the equal sign as a Q, when we're working with helper functions, our Q is going to be actually the colon sign here. So anything that we get before here is called an early completion, but after we conclude the Q, it's time for our completion to kick in. We see that Copilot indeed fulfills this complete successfully. It is very simplistic prompt definition. This is not surprising to us. And we can accept this suggestion. By the way, we could have defined the styling differently. We will see that soon in the next lesson. We could have hanging indents instead of having a one-liner like that, for example. We could have a direct return like this. We could have defined the average with type hints as well and return it. There are a lot of things that we can do here to improve our syntax. More on that on the next lesson. Right now, we're really keeping that to the basics. Um, any questions about prompting for helper functions or anything that we just did? All right, you're very smart. You're picking that quickly. So let me go back to the slideshow and understand what we've done here. I'm going to ditch geometric mean. We will get back to it very soon. So when prompting with Copilot for code completion, use code, right? We see sometimes practitioners that are typing comments in our modules that are specifically supposed to be comments for code completion tools. We don't want to include these comments in our code base, right? So when we are after code completions, we want to prompt strictly with code. We also want to stick to the Stacy framework, having a syntactic flexibility in the constant name and helper functions names. But when it comes to types of the arguments, of the constants, of the return value, we want to be strictly rigid. If we're using primitives, use the primitives. If we're using composites, then use the parameterized generic form rather than the built-in one. And always conclude the prompt with a queue. Anything that you get before the queue is called an early completion. And if you're just getting started, it's probably for the best to wait until you conclude the prompt and not listen to the early completions at first. Our next lesson is how to get longer completions. And for that, so we talked about helper functions, right? And constants. But it turns out that Stacy method can get us so far. But what happens when our actually definition of the function is not enough for Copilot to 100% predict what we want to do? And one of our first examples in the book stems from mathematics, not surprisingly. And one of the examples that we didn't do with the helper function is actually implement the geometric mean. So we've seen the arithmetic mean when we sum up the list of numbers, we divide it by n, but the geometric mean is another mathematical tool to help us understand what is the middle of populations that are multiplicative at nature. For example, if we look on the S&P 500, for example, if we want to compute the average return year over year, we won't average out with the arithmetic mean the returns, right? We will have to multiply the returns that we get each year and then extract the nth root of these returns. So let's just take an example. So if I want to understand the geometric mean of 5 and 20, I will multiply 5 by 20, that's 100. I will take the square root of that, which is 10, and that will be my geometric mean. What happens if we have 5, 10, and 20? Anyone knows what is the geometric mean of these three numbers? A little math for Friday afternoon.
Avi says 10.
And he's right. Why is it 10? Because we multiply 5 by 10. This is 50. Multiply by 20. That's 1,000. We take the cube root of 1,000, and that's also 10. But what happens if, for example, we're computing right now the geometric mean for the S&P returns for the past 2 years, and we see that on the first year we lost 50% net return, and then on the year that follows we got a 100% net return on our invested value. What is going to be the geometric mean here? Any thoughts about that? It's interesting here, right? Because if we strictly follow that mathematical definition, we will have to multiply negative 50 by 100, that's negative 5,000, and then we extract the square root of that. But we hit complex numbers, right? Which is weird because we never seen a 401k advertisement saying that the average returns in the past 5 years is 5 plus 3i, right? We've never seen complex numbers in returns. And why does it happen? Because it turns out that if we face negative values, maybe following that strict mathematical definition is not enough. So to do that, what we do in code is to transform our data from net returns to actually first working with the gross returns. So instead of -50 net returns, we will work with gross returns on our investment. We will compute a geometric mean on that, and then we will take again one from that result, moving back that geometric mean to the terms of net returns. And hence we never deal with negative numbers or with complex geometric mean. So we see here three steps actually, right? We transform the net returns to gross returns. We take the nth root and then we subtract one to bring it back to the net returns. And this is actually kind of a cue to how we are going to increase scopes for these non-trivial cases when we are working with code completions as well. So it turns out that this method is actually pretty common in prompting with text. It's called chain of thought prompt. When in our prompt, we say, okay, the steps are one, move that to gross returns. Step two, take the square or the cube root or the nth root of that gross return multiplication. And then the third step is to subtract one. And our prompts with code should look no different. We will start with the function signature, but then we will describe the steps in code using something very similar that we did when using types that are not yet defined, right? I told you a few minutes ago that GitHub Copilot is very good in completing missing definitions or missing functions or missing imports. And this is exactly how we're going to treat that. So our chain of thought here, and those of you who has done chain of thought for textual based prompts, you will find it very familiar to use that as well when you are defining your higher level of abstraction function. These are no longer helper functions. We're not doing low-level code. We want to reference other functions with low-level details. So this is actually going to be our second exercise for today. We're going to implement the get average returns, which is going to be more complex than just beyond a trivial prompt. Getting objects that describe the net returns, and we're going to transform them to gross returns. We're going to compute the average gross. We're then going to transform it back to net returns. And all of that without writing actual code. Are you ready for the challenge? Let's see how it looks in code. Let me open here a new script. Let's touch lab 2 and let's call it returns. And if we go to returns, we said that our function is going to be called get average returns. But this is not descriptive enough for Copilot to understand what we want to implement in that function. So this is time for us actually to start and defining a prompt that is a bit more lengthy than helper functions, but still also permits Copilot to implement the low-level details. So let's start with our object here. So we mentioned that the net returns is going to be a dictionary. We're still going to apply to the same rules. We want to have the parameterized composites. In that dictionary, we're going to have a string for the year of return and the float for the actual net return. Let me actually also import that so don't get an error. And we would want to get a float back. Now, I'm getting some early completions here, but I know that the prompt is not complete yet. We need a chain of thought. And we remember from our definition of the net return of funds that the first step or the first step in that chain of thought would be to transform the net returns to the gross returns. So what I'm going to do here is to define a variable called gross returns, I want it to be of, let's say, a list of floats. And now, instead of getting a completion, I'm going to call a function that doesn't exist yet, get gross returns. And I'm going to send it the net returns. Now, we see that we sometimes get early completions that we like, and we are going to accept it. And sometimes we get early completions that we don't like. And let me also add here the list. And you see that Copilot completed that by itself. Now, the second step here, it's going to be to compute the geometric mean, right? To multiply all numbers and extract the nth root of that. So I'm going to define gross average. That's going to be a float, and I'm going to say get geometric mean of the gross returns. Yes, that's an early completion I like. And then the net average, Copilot already gives me a pretty decent early completion because I'm getting the type hints, I'm getting the gross average, and I get a subtraction of 1. This is something I like seeing, and then I can return that. So this is kind of a lengthy prompt, but let us see the magic that happens here. When I hit just the enter key twice, you can see that I haven't typed anything, but Copilot already knows that what we should implement is actually that missing function. And if I hit tab here, we can see that I got a full completion of a function. I haven't defined anything except for calling it. But these cues and that context is actually enough for Copilot to understand the styling, the type hints, and also the actual code implementation of getting 1 plus net return in my dictionary. How neat is that? And if I type another enter twice, I also get an implementation of the geometric mean. And we can see that that actually fulfills the geometric mean definition. We start with 1, we multiply anything within the list of net returns, gross returns, sorry, that we're getting, and then we take out the nth root of that, and we get back the geometric mean. How crazy is that, right? We started with a constant that is as simple as getting 3 characters back. But right now, we were able to implement an entire module only by this code. But this is not really a low-level code, right? We just called functions that that doesn't exist yet. It was very simple for GitHub Copilot to say, okay, I understand what you want to do. Thank you for being my tech lead. And then Copilot just implemented the low-level implementations that for us coders may be more difficult than just identifying the steps and saying, okay, this is how I want my higher level function to behave. Any questions about that? Are you surprised? Is this expected? For those of you that are generating code already, is this something that you practice already? Brian, is this something that has come up with your discussions about extending the completion of code? Because this is very different from textual prompt, right? But it's also more fluent for us developers, right? We haven't said like step 1 and wrote comments or so, hoping Copilot to understand what we mean, right? We haven't opened agent mode and said, okay, implement that. We just followed the code practice that we've studied for many years, and we just supercharged our coding. Now, these are exactly the things that I do on my day-to-day job, right? I do my job faster. I'm not changing it. I'm just doing that faster. So I do see that there is a question also in chat. Is Copilot embedded in Visual Studio Code? I can't find it in my Visual Studio Code. Yes, so it's not embedded actually. To use GitHub Copilot, what we need to do is to install an application that is called GitHub Copilot. Now, luckily, you're students, so you can have the education pack from GitHub Copilot and get that for free of charge. You don't have to pay that money at all. So this is great because Visual Code is free and Copilot is free while you're students. So we really have no excuse not to use that and get ready to be practitioners that are supercharging our code. So you do have to go ahead and install this extension. But yeah, you need to create your account. This is free of charge for students. All right, I think that we have for sure. Thank you for the question. So we do get another question here. I would wonder how much of this code completion prediction is due to the keywords like gross and average and geometric as opposed to recommendations based on the actual structure of the function. Yeah, so this brings us back a little bit to the Stacy framework, right? Because we would want to use type rigidity as much as possible, but also things that are most likely to be on the training data, right? We wouldn't want to make up new words instead of average and mean. When we have these words, then we better use these. But sometimes when I code, I have typos. English is not my first language, and sometimes I won't accurately spell things like return or things like gross or mean or average. And even when I have these typos, then GitHub Copilot is doing a really good job identifying that my purpose is actually the main cause or the most probable completion, and I will still get some pretty neat results for that. Um, yeah, and Brian, thank you so much for sharing the GitHub Student Developer Pack. This is indeed what the students can get for free. Um, all right, fantastic. Any other question? Okay, let us understand what happened here. We talked about chain of thought for data flow, right? Because it was very simple for constants and helper functions, right? We just followed the Stacy framework, and we got the completions. But when we want to level up and have higher level definition of functions, this is time to apply chain of thought for the data flow. And then we are actually able to get longer completions. We not only get entire modules like this, we also get better code, right? And this is exactly the production code I was talking about at first, that we get actually production level code instead of just vibe coding when we get spaghetti things that do not necessarily work, and reading that is a nightmare. Here, when we apply chain of thought, we get the style we want, we get production code quality, and this is far better than just using texts like anybody that didn't learn how to code can do. Next, I want to discuss very briefly about GenAI code smells. And this is actually a super important lesson I wouldn't want to miss. Because when we start with prompting and even vibe coding, it's almost like we're sewing off the branch we're sitting on, right? Because generating code is pretty neat, but we also must remember that we write code just once, but we read code many times. And I'm not the first person to actually think about that. In 2007, a practitioner that is widely known named Robert Martin, aka Uncle Bob, released the book Clean Code, and he's talking about clean code principles there of how to better write software code that doesn't completely suck. And one of the first concepts on the book was the dry principle, that do not repeat yourself. But unfortunately, when we are writing code, if we go back to the constants file, let's say I would want to implement another constant, pi, for example, GitHub Copilot will actually tell me, okay, this is how to implement pi. But this is not what we want, right? We have a standard library that is called math, and we can actually import the value of pi. So repeating ourselves and re-implementing pi is something that we're not bulletproof from when using tools like GitHub Copilot. And actually, when we're working with practitioners and students, and even when I review pull requests, I often see reimplementations of constants and reimplementations of functions like standard deviation that already exist in standard libraries. And as developers, we really want to avoid these scenarios. So my take from this lesson, it's going to be pretty quick, is just understand that prompting with code is not enough. Even if you get extremely good at it, you need to remember that you're the tech lead, and GitHub Copilot or Cursor or ChatGPT are only here to supercharge it, to assist you, but you are the tech lead. And with that lesson, unless you have any questions about how to dodge the code smell, I would like to quickly wrap our discussion up. So, do we have any question on dodging the code smell bullet? Fantastic. Let's wrap it up really quick. So I promised you that in 50 minutes, you will know when to use GenAI applications. You will understand better the intuitions and why you're getting the results you're getting, and also how to practice. We understood that we want to use GenAI like GitHub Copilot for code completion tasks. And we also use the Stacy syntactic flexibility, type rigidity, and a queue for simple prompting. And we also use the chain of thought for data flow for more complex tasks. We understood that Copilot stayed predictable when our prompt got predictable, but when we used different type hints for the same constants, we got different results. So as long as we are staying predictable, the completions that we get will also be predictable, which is where exactly we want to be. And now this is time to understand how to practice, because throughout this session, we did give or take 15 prompts. When I code with GitHub Copilot and when practitioners I've talked to code with GitHub Copilot, we get up to 80 prompts per hour, and that's huge. When we work with ChatGPT, we keep it to maybe 5 or 10 prompts, 10 conversations per hour, but with GitHub Copilot, it really supercharges our coding work. And this is exactly where I want you to get. If in the next week you will practice 10 hours with GitHub Copilot, it means that you effectively can reach as much as 800 prompts, and that's a lot to understand what's in it for us. Of course, today was just scratching the surface, right? We haven't talked about variable definitions, about building mock data for tests. We haven't talked about defining many constants together, or migrating data structures, or doc strings, or tests, or a lot of other things. And exactly for that, we have the book Supercharged Coding with GenAI that is also available for you throughout the O'Reilly platform. And I really hope that you get a chance to look it up and see if there is any value in it for you. And in the last slide, I will be very happy if you keep in touch with me. Here's my email address. I also have my LinkedIn profile and also my TikTok account. I think I should replace this QR code, but let me know if you can't find it. And yeah, thank you so much for your time today. And I hope to hear from you.
Awesome. Thank you so much, Sheila. That was fantastic. I just
Yes,
put
for
something in
sure.
the chat, O'Reilly books. If you go to O'Reilly.com and you sign in, you can sign in with a single sign. Actually, if you just put in your emails or a call, if you put in your Boston College email, it will ask you, do you want to do a single sign on? It'll have you authenticate with your BC credentials. You can go in, you do the search for Supercharged Coding with GenAI. You'll find the book. It's right there. It's electronic format. And I should also say, for just if you don't know the O'Reilly.com site, there's equally thousands of books that are there that are just really, really useful around generative AI. Certainly all of us in the data science world doing that, that's just a lot of great, great resources there, machine learning resource, all kinds of stuff. So that's the digital stuff. Before I get to the special bonus lucky attendee part, are there any questions for Hila. And I want to just start by with one you asked me sort of, but when you asked us, are there things I guess maybe that were sort of surprising? And I have to say that each time I use these things, there's always some point where I'm like, wow, that's wild, right? And to think of this as right, it's just so everyone knows, right? I mean, this is one of these things, right? That computer science, automated programming, this notion of doing this has been around for decades,
For
decades.
decades, really.
And
Yes.
it really has been this interesting pursuit of how do you write programs that generate programs? And the difference between data and computational power and things like that, right? Make an incredible difference. But I think, it's also in terms of some of the design things that we've learned along the way. And I think these environments like embedding Copilot into Visual Studio Code or Cursor or I mean, those are some of the surprises where I'm like, wow, that's like nuts that you can type a comment and it just generates stuff because it's seen so many examples of that. And then, of course, there's the cases where you go, oh, it doesn't know anything about that. But the fact that you can lead it down that road, I think the chain of thought example is a really great example that you showed, right? Where you can actually sort of like push this thing into a point where it goes, okay, I don't know that, but you just showed me that. And I know these primitives enough that I can help there, right? And so that it's still us in the loop, I think. And that's a really kind of exciting
Yes.
thing. So it's I think one of the things that I guess we certainly talked about at that meeting I mentioned early on, and I know that's in the book, is it's not quite stated the same, but we tell people there's still something that you need to know, right? In order to
Yes.
do this, right? And so what we would call that in fancy, my PhD is in something called the learning sciences, where we study how people learn. And so, we get very theoretical. And one of our big notions is you have to have a clue to get a clue, right? That's
Yes.
that's PhD talk. Right. And it is this notion that, right, it's the better these tools will be better, the more that you know and how to bring things to them, right? And I think that your demonstrations were really I really like the way that you illustrated that by saying, look, we think about chain of thought prompts, and that's very much the way that we're thinking anyway. We're laying this out as what do we need to like actually solve this problem, break it down into the proper steps. The machine can do some of it. We have to teach it some of the things, but understanding algorithms is still important. Understanding sort of like where my goals are still important, right? And decomposition and all of those things. So that great examples. Thank you so much.
Thank you. Thank you, Brian, and thank you all for joining. I'll be happy to hear from you.
Yes. Any questions?
All right, it looks like this is it, and I also have to drop.
Okay.
So, yes.
So let me just announce the winner. And by the way, the winner was chosen today by, of course, Python with random random dot randint. I mean, come on, like that's how we have to do things. So, well, I sure let's see. Kathleen Flanagan, are you still? There was a Kathleen Flanagan on earlier. I don't see.
Yes, I think she dropped like a minute
Oh,
ago, so.
okay. Well, then you know what? Hang on a sec. I just gotta read this. Then it looks like Siming Chen. You are our lucky winner. If you want to send me, yeah. Send me here, send oh wait a minute. Okay, sure.
Sure, I will send you
Okay,
an
great.
email. Okay,
Absolutely.
great.
And then I will
Thank you.
we'll get you all connected up. And so congratulations to you. Remember, all of the rest of you can get the book online at O'Reilly.com. Hila, thank you so much for joining us today. Fantastic
Thank
talk.
you for having me. Thank you,
Appreciate you
Brian.
sharing knowledge with us. Thank you so much.
Bye bye. Thank you.
Everybody else, thank you for joining us today, and we'll see you at the next session. Take care. Have a great weekend.